next on stage is Philipp Drieger from Splunk. Welcome to the stage. And you will talk about operationalized AI for successful business resilience. You are working as a global principal machine learning architect as Splunk. And looking forward to your impulse now.
Super, thank you. Thanks for having me. Great to see you. We already had a chat at the lunch break. I'm not colorful today. I choose blue. I don't wear a glass, so you can see multiple appearances of maybe the same person. Maybe I confused a few people, hopefully not you in the room. As said, Philipp, my name. Feel free also to find me afterwards, and I'm happy to tell you a bit more about Splunk. Maybe just to keep it a bit interactive, who heard about Splunk before or was reading something? So a few hands. Then you know already something. The rest of the room will know a bit more later on. I hope this is also covering some of the introduction. This is the slide I always must show. That's company policy. Any forward-looking statements that I do about future product features or anything like this, please only take granted what is available today. With that, digital resilience or business resilience, I think, is a main driver and a main factor for all organizations these days. We are heavily on a digitization journey. Every business process, every product needs to get more digital, which also opens potentially attack vectors for cyber attacks, for maybe people who want to use your services or applications in not the desired way that you designed them to. So this is a big risk. And there's a report we have been conducting that companies who apply machine learning, and we don't want to start a philosophical discussion what AI is, what ML is, what deep learning is. I think everyone has an opinion in the room, and I think it can be a fruitful exchange about this. But in general, companies who use these technologies are likely to be more robust, more resilient, better, let's say, to stand up if someone falls down, to speak in a picture in terms of a cyber attack, for example. So I think this is really a big driver and a big motivation for many companies to look into this. The approach of Splunk here is to really provide a unified platform. We had, with the talk before, also talking about a platform that enables, of course, integrating, ingesting data at scale. This is what you see on the bottom layer. All varieties from logs, metrics, traces, any event, IoT type of data. If you think about sensors in a production line facility, I will come back to that in the two examples I share later from customers. And this is what you can see, the gray kind of in the background working effect of a Splunk AI. And this can really unfold into different ways: classical machine learning, data science, custom purpose-built things that customers are doing, or pre-canned AI models that are available to effectively build better security and better observability-based solutions. This is mainly the mission and the goal. Underpinning, of course, within the topic of digital resilience to get more resilient as an organization. Now, with that, a bit more narrowly, the approach we choose to take in Splunk around AI projects, features, functions, capabilities is mainly first of focusing domain-specific on security, observability ones, but this does not exclude what you can see on the very right side to be open and extensible, to integrate with any third-party other solutions, software vendors, and make a more compound, greater solution. In the center, you see human in the loop. This is probably a concept you have heard of in the one or the other occasion around topics how we as humans might interact with AI in future, namely being in the driver's seat, hopefully, as long as we can. I don't want to paint any science fiction stories here, but effectively to keep always the human in the loop. I think all of you have experienced what AI systems can do, where they might fail miserably. I remember the discussion we had during the lunch break as well. So I think always a human needs to be somehow connected, entangled, integrated into a workflow that is somehow consisting of AI. I mean, there could be other opinions. Happy to discuss afterwards if there are other opinions around that. But at least this is what we are following, mainly in the offerings of our solutions that we are having. Now, to share a bit more real-world customer use cases, customer success stories. I would love to bring all these customers on stage. I could not convince everyone to come with me to Berlin to join me at the talk at this conference, but those are public references that we have worked on in the past, and to also make sure these are use cases that are in productive state. This is not like we POC'd something, we did something here. This is really an operationalized AI application of those things in practice in all the different organizations that use Splunk. A few of them, I will spotlight and deep dive into the two on the right side, BMW Group and Zeppelin, but also just to reiterate on the cybersecurity part and to rephrase what Siemens as a big, large organization, of course, is doing. One of the most highest secured data centers is being, of course, run 24/7. A lot of stuff behind it. Most business critical applications run there, and you need to make them as secure as possible, of course. That's kind of a must and a given as well. Then what they did, they used, for example, machine learning algorithms in conjunction with the Splunk platform on all of the varieties of their data to specify specific use cases like detecting unusual communication of a host system in this whole data center. What is happening with this host? Why is it suddenly sending data into a place that is not thought of or not intended to? So these are the applications that are specifically of interest for a security analyst who needs to know what's going on in such a big data center and really knowing if something goes wrong or not expected, then to have a direct way to investigate this. So this is just to recap a bit what they are using Splunk for. BMW Group I will come into in a minute, and Zeppelin as well. This is a bit more industrial operations related / business use case related, but you will find out more detail when we dive in. For BMW Group, they have a so-called tech office in Munich, one of the, call it innovation centers. I would coin it as an external observer of what is happening there. So a lot of applications from computer vision to more advanced, also GPU computing related things, including virtual reality, production related optimization projects. So kind of a think tank and really an innovation lab. Now we had a good working relationship with them to actually look into testing strategies. Now, for those of you who are working in automotive, for those of you who are not working in automotive, the basic idea is you want to build a product of course, the best possible quality for your customers. You don't want to ship a crappy product that is not usable, most likely not, hopefully not. So you want to ensure the quality. Now you have quality assurance, but on the other hand, you can also take the challenge, what they did, and say, can we use the data about our products that we build? In their case, of course, namely cars, vehicles in general, if you include the motorcycles, and then say, can we learn from all of the past built cars and all their configurations? And if you configure a car today, you know this is a highly individual process. You can change the color, maybe if you include the steering wheel from left to right because you ship to the UK or to some other country that is not following the usual things that we are used to have here, then you see it as a highly, let's say, high cardinality data problem as well, because so many permutations, combinations come into place. And this is, of course, then a challenge more on the data science and machine learning side, where you want to use this data to predict if during the production process there might be certain challenges occurring, including maybe errors that need to get fixed. If you need to fix something during the production, for those of you who are associated with production processes, you need to take something off the line. You need to do rework. You need to put it back into the process at the right place. So this is all consuming time, material. Of course, sometimes maybe you don't find the error easily, then larger problems are occurring. You have maybe another special analysis facility where you need to send stuff to. So a highly complicated process if it goes into that. Luckily, the production is running very stable, but still, if you think about very newly introduced cars or very rare combinations that are occurring in this configuration, then this matters more. Now, what they tried to approach and were successful with it is actually using a deep learning strategy to say, we build a neural network. This is deep enough to capture all the varieties and all the high cardinality information from the car configuration and also the process information around what the stage the car is maybe currently in and so on. Then this is combined and being projected. I use projected. Other people say it is predicting a certain target variable. In this case, for example, if a certain error was occurring. So this is mainly what was happening here. The conclusion from this project was data quality. I think this echoes a lot what we heard also at the conference around building a model is maybe the not so big step in the full chain. If you look at from an end-to-end perspective, the data engineering, data quality checking, curating a high quality data set to solve this. This is another big portion that was going into this. And classical machine learning approaches, we tried a lot and they tried also a lot in their lab. We're not really succeeding for this given data set. So this is really a good reason then, I think, to go to more complex methods like deep learning strategies if needed. Otherwise, I would always try to apply the famous Occam's razor, if this is a word or a term for you, to say, keep it as simple as possible first and only increase complexity if really needed. But maybe just to rephrase and recap a bit. Speaking in pictures, I think I already explained a lot, but simply put the challenges, you can, of course, increase the resources you put into your production process and, of course, have associated higher quality output. And on the other hand, the process efficiency is potentially getting increased. Now, you can read from this curve, potentially going to even more efficiency, you need to add a multiple of more resources. And this is where you have a natural cutoff. So you cannot infinitely spend money or resources on a process. That's why you want to find an optimum, call it exit point. And you can see this transition from the point 2, what the status was before the project, more towards the 3 to really move the needle here in terms of getting more efficient with more or less the same resource investment in terms of the production process. The right picture depicts a bit the schema of, call it more from a procedural logic, what is happening. The cars are being built. Now, if you can decide as early as possible what is potentially wrong later on, then this saves the most. I mean, it does not help you. The car comes to your current station and then it says, hey, something is wrong now. Maybe not the right person is here to solve this problem. Maybe the wrong spare part is missing that you actually need to catch somewhere from somewhere else. So the earlier you know, the better you are off to, of course, then be successful in efficiency gains. So this is in a nutshell what they did. To show a bit more on the data science, machine learning side of the house, on the left you see a little galaxy. I compared to the universe. You can see little clusters. All the little dots you can imagine, this is one car and its very specific configuration. We used a feature reduction technique or dimensionality mapping technique called UMAP to transform this very high cardinality feature space into a lower representation. In this case, it's a 3D scatter plot chart. I cannot animate it. I should produce maybe an animated GIF for future, but you could imagine you can fly into the space, look into detail what is in this cluster. And then you can also try to run simple things like a clustering algorithm on top of that to say, okay, great, where are groups of most likely very similar configured cars? And then the next step occurs. You could say within such a cluster, let's look at the error rates. Hey, we find maybe, I don't know, I'm fantasizing this, the right-handed wheel driving with the blue color is suddenly having a different rate of errors. And then this gives a very good investigation point for people to look into and say, why is it? Is it the blue color or is it the other position of the steering wheel? So this is the interesting findings that their engineers then were, of course, looking for and learn more how can I better do my processes. For the deep learning approach, you can see a classical, let's say, input, dense layer structure and output. This was trained on a GPU, including all the different metrics, the scoring you need to do. You have your training data set, your holdout test data set, and then measure against, of course, unknown data points to make sure your model is generalizing good enough. You can really capture the relevant patterns that are arising. So this was kind of in the testing and development phase, including all the different tools. You can see little Splunk dashboards as well that allow to bring all this information easily together, to present it to different stakeholders, including data scientists or engineers. So that's what we have mainly been working on. The end result looks, I don't say boring, but you could say it's a simple representation of the key information. So of course you want to hide all the, call it data science, AI complexity in that sense to say, what is the end result? As a user, as someone who wants to consume the information, I just want to know what are certain portions, what is a ranked list of maybe the top 10 most critical things that I need to look into today. And if you want to filter and go a bit more into details, you see this little parallel charts coordinate down below, where you can easily see over different dimensions how the patterns are working together. And you could select, I stay with the right-handed steering wheel. If I choose this, what is all the other things that might be impacting? So that's kind of a result in the finding. Explainability, or what we also, I think, I'm picking again our conversation at the lunch break that we had, transparency of models, explainability, interpretability. I know there are nuances to that, so we could dissect into each and everything of these details, but what was most meaningful for them to also understand which features in my model are more or less impacting on a specific given outcome results. Remember, the outcome, the target variable would be around what is a potential error pattern. So this is a bit what we did here. Now I need to speed up a bit on the next use case to rephrase it or to reframe it. Good news is also to share here. There are presentations around these use cases publicly available. You will find them if you know the few keywords in your favorite search engine to look for. With Zeppelin, the challenge was a bit different. We had more a predictive maintenance situation where you see these big power generation machines in the end. They generate heat, they generate power. Over 70 plants across Germany are run. They are then operated and as a service contract offered by Zeppelin to whatever customers, including, of course, also public authorities and anyone who needs power and produces them. Now, from time to time, some of these machines break down and you need to send a technician. If the machine is down, it does not produce energy, so you have an outage. What they did here is, first off, reading in, I would say, German engineering, hexadecimal, incredible, interesting data. So we were, first off, transforming this into a better readable, better analyzable result. And once we had this, you can see at the middle center chart, everything is running more or less stable. And this is just one out of over 200 different features. You see the cylinders, and one of these cylinders is spiking up, another one is going down a bit, and then there's this big gap in the middle where the whole machine shuts down and is not producing the things. The scale is too tiny to read, but this was over the weekend even worse. So getting a technician on the weekend exactly to a specific plant, maybe not the easiest thing to do or to do it quickly. Now on the top you can see an anomaly signal that is being produced with the help of unsupervised learning strategies to look over multiple of these features and give an early warning indicator. Hey, here is something going wrong. Better you know already now, instead of the machine breaks down and then you need to investigate. So this is what is currently productive at a also operation center that they run for all the different plants, collecting the data in real time, then running all these models and also embedding this into their service workflows and make sure that the information is actually used in a proper fashion. So the results are, of course, you can guess it, less outages. A cost perspective is, of course, involved as well. So you save something, you have better service quality, you have better service uptime. So I think all beneficial factors for the company and this business. With that, I'm out of time. One pointer, I intentionally used little QR codes or a bit bigger ones in case you want to go directly to the page that I'm referring to. The one is getting started with machine learning at Splunk. We have several apps that you can explore. Parts of them are open source as well, so you can explore a bit on the technical side what's there. And I wait for the gentleman to get it. You have it. And the last one, in case you want to connect with me, feel free also to find me on LinkedIn. And with that, I can now do the countdown. 10, 9, no, joking. So I try to stay in time. Thank you so much for your attention, and I'm here all day.
Thank you. And before you're looking for the QR code, you have the chance now to ask one or two questions live now on stage.
Whatever the time permits. So you decide.
Yeah, we have 2-3 minutes left.
Okay,
so
great. Then
I will open the floor again.
Please. Yes. So good news is there's also a public presentation about it. If you connect, I'm happy to send you a PDF link directly, or you find it on our Splunk Worldwide User Conference pages, where all the talks of other customers are recorded and they are public information. So we had 3 use cases. The first I mentioned was around anomaly detection of, let's say, network traffic from a host system or a server, you could say, to the outbound world. Simply put, this was one. The second was, if you are a hacker, you make it to a system, great. You don't have all the great tools you usually have. So you need to do an approach that is called living off the land. So you are on a system, you need to work with effectively the command line tools that are available on this specific system. There's a specific security concept. And then you could do things like ping. What's in the network? You could try to raise your own users' accessibility rights, if possible. And this depends how strongly secured such a system is. In a nutshell, you can also collect all the information that you leave by entering these commands on the command line, simply put, and collect this in a platform like Splunk to analyze. Now, what we did then is we had like a positive list, positive labels, you could say, of known sequences of living off the land attacks. This is what hackers might do, or what is known from other research security-wise, what is possible, and you have all the rest that is happening in the environment. And then you could say this is all assuming negative. Then you put this together into a training data set. You build a bit of TF-IDF or some vectorization of the words to get like a numeric representation, and then running it into a classical classification algorithm to say, okay, great, I see these and these sequences, and point it then to the one or the other label. So this was the second use case that they implemented. And with the benefit, imagine you have on a daily basis 20 million command line activities. It's not like in the science fiction movies where a hacker is in front of the computer screen and you see the log lines running through and then, here is it. That's unrealistic to do. That's why those techniques are super beneficial. And the third one was, it's actually a collection of 3 use cases we packaged in a presentation around, call it behavioral analysis with regards to, imagine you have an administrator account. You can do a lot. You usually do only good things, but imagine for whatever reason your account gets hacked by someone who is not trying to do good things. Then, of course, this is highly critical because they could manipulate systems, data, do whatever harm to an organization. Therefore, to protect those so-called highly privileged user accounts in a better way, to understand how they usually operate in, of course, German data privacy fashion, anonymized, so we don't really profile what user is doing what, but to find out when suddenly the behavior of a user is changing, to give a security analyst an alert to say, hey, this is suddenly doing something very strange. So it is also with the German Betriebsrat type of fully, so to say, in alignment because it is protecting an organization's properties. Therefore, for those cases, and you could call them edge cases, you are allowed to do certain analysis, of course, within the given regulatory framework. But this was the third one we looked into and improved, therefore, how users are maybe behaving in a network. And in the worst case, which luckily never happened up to the current point in time, if something works in this direction, then you could detect it early on instead of later. And the later it takes, the more harm potentially gets caused. So I hope this helps to give a few more use case ideas. And as I said, happy to share the presentation. I don't have it with me, but yeah, virtual world. I wish I had a stack of paper I could maybe hand over. Yeah.
Yes, thank you.
Okay.
Perfect timing. And the next name and face already appeared on the screen. So thank you, Philipp.